Assalamu alaikum. Question number 2. This question is from June 22, 41, paper 41. Two particles P and Q of masses 0.5 and 0.3 kg respectively are connected by a light inextensible string. The string is taut and P is vertically above Q. This one is particle P. This one is particle Q. Attached with a light inextensible string. String is taut. With respect to P, the tension is away from, with respect to Q, the tension is away from Q, and with respect to P, the tension is away from Q. In this string, the tension is same, T. Weight of P is will act downward, 5 Newton. Weight of Q will act downward, 3 Newtons. A force of magnitude 10 Newton is applied to P vertically upwards. 10 Newton. Find the acceleration of the particle and the tension in the string connecting them. We will consider this system as a single object. Now we will apply the second law of motion. F is equal to ma. Force in the direction of motion is 10. Now the force opposite is, one is 5, other one is 3. This tension will be cancelled by the other tension. So there is no need to mention this tension in this formula. The only forces are 10, 5 and 3 is equal to m. The mass of whole system is 0.8, 0.3 and 0.5 into A. And the final answer for A is 2.5 meter per second squares. Now, we want to find out the tension in the string. Now we will consider the object Q only. And we will apply the Newton's second law of motion. F is equal to ma. Now, the force in the direction of motion is T. And the force opposite is 3 is equal to 0.3 into A. A is 2.5. So the tension in the string is 3.75. This one is the final answer. Question number 7. This question is from June 22, paper 41. Two particles A and B of masses 0.4 and 0.2 kg respectively are moving down the same line of greatest slope of a smooth plane. The plane is inclined at 30 degrees to the horizontal and A is higher up the plane than B. The plane is inclined at 30 degrees to the horizontal with A higher than B. On the plane. A has the weight 4 Newton and B has the weight 2 Newton. When the particle collide, the speed of A and B are 3 and 2 meter per second respectively. In the collision between the particles, the speed of A is reduced to 2.5. Find the speed of B immediately after the collision. We will use the law of conservation of momentum to find out the speed of B. We will write down the data for this part. Mass of A is equal to 0.4 kg. Initial speed of A is equal to 3 meters per second. Final speed of A is equal to 2.5 meter per second. Mass of B is equal to 0.2 kg. Initial speed of B is equal to 2 meters per second. And final speed of B is unknown. So, law of conservation of momentum is m1u1 plus m2u2 is equal to m1v1 plus m2v2. 0.4 into 3 plus 0.2 into 2 is equal to 0.4 into 2.5 plus 0.2 into x. The final answer for x is 3 meters per second. So the speed of B after the collision is 3 meters per second. Now, we will move to the next part. After the collision, B has moved 1.6 meter down the plane from the point of collision. It hits a barrier and returns back up the same line of greater slope. B hits the barrier 0.4 seconds after the collision. And when it hits the barrier, its speed is reduced by 90%. It means after the collision, the speed of B will be 10% only. The two particles collide again at 0.44 seconds after their previous collision, and they then coalesce on impact. Show that the speed of B immediately after it hits the barrier is 0.5 meters per second. We want to show that the reduced speed of B is 0.5 meter per second. Hence, find the speed of the combined particle immediately after the second collision between A and B. First of all, we will show that the speed of B after hitting the barrier is 0.5. We will consider the motion of the particle B after the collision. After the collision, the speed of the particle B is 3 meters per second. The distance from the barrier is 1.6 meters. We will find out the acceleration of the particle B. We will apply F is equal to ma. Force in B, the force in the direction of motion is mg sine theta. This one is mg, this component is mg sine theta. As the plane is smooth, so there is no resistance force. Mg sine theta minus 0 is equal to m into A. A is equal to g sine theta. And the acceleration is 5 meters per second. Now we have the distance. We have the initial speed, we have the acceleration. We will find out the speed of B with which it will hit the barrier. We will use equation of motion 2as is equal to v square minus u square. Acceleration is 5, distance is 1.6 from the barrier. Final velocities are known, initial velocity is 3 square. From this equation, we will get the velocity, and which is equal to 5 meter per second. Now, the particle B will hit the barrier with a speed of 5 meter per second and rebounds. When it will rebound, the speed will be reduced by 90%. So the speed will become only 10%. 10% of this speed is now the speed of the B after hitting the barrier is 0.5. Question that B hits the barrier 0.4 seconds after the first collision. First collision happened at this place, the two particles A and B collide. Now it took 0.4 seconds to hit the barrier, and then its direction is reversed. The particle B will move in this direction. The total time for the downward motion and the upward motion is 0.44 seconds. The time for the downward motion is 0.4. So the time for this segment is 0.44 total time minus 0.4. So the time for the upward motion is after hitting the barrier is 0.04. Now for particle B, for the upward motion, initial speed is now 0.5 meter per second, which is 10%. Acceleration will be again g sine theta, that is minus 5 meter per second square. Now the particle is moving in the upward direction. Force in the direction of motion is 0. Force opposite to the direction of motion is mg sine theta is equal to m into A. A is equal to minus g sine 30. A is equal to minus 5 meter per second square. And time is equal to 0.04 seconds. Now we will apply equation of motion V is equal to U plus AT. V is equal to 0.5 minus 5 into 0.04. And the velocity is 0.3 meters per second. This one is the velocity with which it will hit the particle A for the second time. Now we will consider the motion for the particle B, A. The initial velocity of the particle is, after the collision, is A is equal to 2.5. meters per second. Time is 0.44, and the acceleration, the calculation of acceleration is again mg sine theta minus 0 is equal to m into a. Acceleration is again 5 meters per second. Now we will use equation of motion to find out the final velocity. V is equal to u plus at. V is equal to 2.5 plus 5 into 0.44, and the answer is 4.7 meter per second. Now we will apply the law of conservation of momentum to find out the speeds of the particle after the collision. The two particles again collide 0.44 seconds after their previous collision, and they coalesce. Now, mass of A is 0.4 kg. Initial speed of A is 4.7 meters per second. Final speed of A is unknown x. Mass of B is 0.2 kg. The initial speed of B is minus 0.3 meters per second. Now the speed of A is downwards and considered positive. The speed of B is upwards, and we will put a negative sign with the speed of B because this one is in the opposite direction. The final speed of V is x. Both particles will combine after the collision, and the speed of both the particles will be same. Now we will use law of conservation of momentum, that is 0.4 into 4.7 plus 0.2 into minus 0.3 is equal to 0.4 into x plus 0.2 into x. 0.6 x is equal to 0.4 into 4.7 plus 0.2 into minus 0.3, and x is equal to 3.03 meters per second. The two particles will move in the downward direction because the velocity sign of velocity is positive and downward velocity is positive. The two particles will move downward with a combined velocity of 3.03 seconds. Thank you.